In contrast to Earth, Mars has a very old surface and a very old crust, and that gives us the opportunity to look back into the history of the solar system, to the early beginnings, to the formation of the planets, and also to the formation of life. Mars dramatically changed its climate, mostly due to thinning of its atmosphere due to the solar wind, which takes atmospheric molecules with it. That's a reason because Mars has no magnetosphere. Other problems for Mars are changing of the rotation axis and the inclination of the rotation axis, which makes polar regions to tropical regions and equatorial regions to polar icy regions. All these climate changes seize down the processes on the surface and make Mars a very cold and dry environment today. We have a lot of evidence of water on the surface of Mars. We see valleys with riverbeds within these valleys. We have traces of lakes. We have traces of glaciers. We have water on the Martian poles today, and we also know that there is water as ice lances in the subsurface, and we still see some changes on the surface which we are very sure they are due to the action of water. The major goal of the Mars Express mission is to map the Martian surface and the Martian subsurface. The German camera experiment, which is a stereo camera and provides a three-dimensional mapping of the surface, really gives us a good feeling how processes on the surface like water flow, formation of rivers, formation of lakes really worked on Mars. And in combination with other instruments like spectrometers or radar, we are able to look into the subsurface and see what the chemical evolution of Mars was in former times, and it was really a surprise to see that the Mars completely changed its climate conditions from very basic to very acidic and really down to nothing more than a desert.